Okay, we're looking at Math 2, Unit 3, Lesson 5. This is Form K from the textbook. Alright, looking at isosceles and equilateral triangles today. First, let's complete each statement and explain why it is true. You have to write out some explanations for yourself here on these. I won't go through all the explanations. But we have AB, which is there, and it wants to know what it could be congruent to. We could say it's congruent to AC. I could say this one here, I'm going to put a hash mark there, is congruent to that one, AC. And the reason I might say that is because they share on the base the same angles, which makes an isosceles triangle, so that's why they're going to be congruent there. You can do the same kind of thing. You can look at number 2. We have B angle BDE, which is here, this angle here. And what's that going to be congruent to? Well, again, it's an isosceles triangle. So because isosceles, I could say it's congruent to BED on the other side, and that's because they have isosceles legs here, and that's the base angles there. CBE is congruent to something, which is congruent to BCE. Looks like we're just trying to show that this angle CBE here, and we have BCE here. What's missing is the one in the middle, which should probably be BEC. Angle BEC is also going to be congruent, and the reason that's going to be so is because all the angles of an equilateral triangle are going to be congruent. That's what makes the equilateral 60, 60, 60, and you're set there. Moving down. Number 4. Some of these numbers are a little hard to read, so I'll rewrite them a little bit for you. Okay. We have an x value here in the top. We have a y value, which we're trying to figure out for this space right there. We have 120, 120, and we have a 45. All right, we have to find the values here of x and y. So let's start with the x value. If I have a 45 in this corner and we have two it's an isosceles triangle. If this is a 45 in the base, then this other angle will also be a 45. 45 plus 45 is 90, and because the triangle, what that leaves me up in the top, what's remaining for x, is going to be 90 degrees. If that was too quick, I could do 180 minus 90, and it equals 90 degrees. Okay, down on the next one, we have an angle of this isosceles triangle. We have 120 degrees down this bottom here. Okay, little extra step here. If it's 120 degrees there and I have two angles left, I have to see what's left. So I take my 180, I subtract 120, that's what's up at the top angle, and I have 60 remaining. But that 60 has to be shared between both of the base angles equally. So I do 60 divided by 2, and that tells me that y is going to be equal to 30. So x equals 90, and y equals 30. Okay? And that's what we get for number 4. Okay, looking at number 5. Number 5, we have a 4x over here. This is indeed a 4x. And we have a y out here on the outside of this triangle. Okay, this is an equilateral triangle, which we had back up in the first set of problems. Because it's equilateral, that means that each angle is going to be 60, 60, 60. So I can actually set up an equation right here to say that, well, 4x is going to equal 60 degrees. I divide both sides by 4, and x equals 15. Oops, a little off the page there. Okay, sorry about that. So I set it up again, 4x equals 60, divide both sides by 4, x equals 15. So if I know that x is 60 there, then what's left on this, because it's supplementary angle, is 180 minus 60, leaving me with 120 for the value of y. Let's say, for example, you didn't remember what this was equal to. You didn't remember that equilateral was 60 on each corner. Well, hopefully you would know that it's 180 altogether, and I could take that 4x and I can multiply it by 3 times, because I have 1, 2, 3 of those, which would make it 12x equals 180. I could try to solve that, but I still end up with x equals 15. But, so you don't have to worry about that. That's just if you weren't sure that these were all 60. Okay, moving over here. This is a good little problem here. I have an equal side, an equal side. I have an x value in this corner, an x value in this corner, an x value there, and I have a y value here. In this worksheet, for some reason, when I print it off, it cut off that this angle measurement in that space is 37 degrees. So I'm not sure if yours has that or not, but it should. And that, also equals as well. So when I look at this triangle here, what I notice is that I have lots of things going on. I have 37 degrees over here, which means that I have, if I look at this triangle, I have an isosceles triangle on its side. I have a line and a line segment. Those are equal. If that's 37, that means that right here, this angle is also 37 degrees. Okay, so 37, 37. We're doing okay so far. And if that's 37 there, because these are corresponding parts here, that means that this one over here is also going to be 37 up in my y category. And I say that so because I have a line here and a line here for this isosceles triangle matches this one there. So we're going to make that 37 in that corner. So y equals 37. And again, if this corner is 37, then I can make that one right there 37. And now I'm left with figuring out what x might be. Go, what could x be? Well, if I have a triangle, let's just draw one of these triangles out by itself here. And I have a 37, and I have a 37, and I have an x plus 37. Is what's left in that space there. All of that has to add up to equal 180. So essentially what I'm saying is that I have a 37 plus 37 plus 37 plus x is going to equal 180. When I add these up, this combines to make 111. So when I do 180 minus 111, what I'm left with is 69. And that becomes my value of x. So x equals 69. Kind of a roundabout way of doing it, but just kind of how I looked at it that time. There's other ways I'm sure to get there, but I just kind of went around the triangle and landed there. Okay, number 7. Looking over here. Zoom out a little bit for you. Okay, it says if angle ADB right here is 54, lovely. Then CBD is equal to what? So what is this guy right there? Well, again, it tells me that angle matches that angle, which means that this is 54. And if those are both 54, then I'm in pretty good shape so far. Because it's 54, 54, I can do, that's 108 combined. 54, 54 is 108. I know that the other angle missing measurement here is 180 minus that. And so 180 minus 108 is 72 degrees. And so 72 degrees is what's going to be left over here. 72, 72. And this angle measurement they said was 54 already as well. So that's a 54. And so since that's a 54, and I have 54, 54, and 72, and I have matching parts there, I'm going to go with it. This one is also going to be 72 degrees as well. All right. If line segment AB is equal to 8, then what is BD going to be equal to? Well, because those are the same base angles, then this part has to also match. So BD also has to be equal to 8. It's the only way to do that one there. It's isosceles triangle. All right, number 9. You're asked to put up a V-shaped roof on a house. So let's put our V-shaped roof up on our house. There it is. Isn't it just fantastic? V-shaped roof on a house. The slope of the roof is 40 degrees. Okay. What is the measure of the angle needed at the vertex of the roof? So the slope of the roof here is 40 degrees. And the vertex is the top point here. And they want to know what is this supposed to be right there. Well, It's a V-shaped roof, which means it's an isosceles type of roof. It's a V. So I'm going to have 40 there and a 40 there. So my base is going to be equal to 80. And a whole triangle would have 180. So 180 minus 80 leaves me with 100 degrees available for the top of the roof. Number 10, the measure of one angle of a triangle is 30. Of the two remaining angles, the larger angle is 4 times larger, 4 times the size of the smaller angle. So 4 times the small angle is 30. Let's go with that's 30. If this is the smallest one, 4 times 30 is what? 120. So is a triangle isosceles? And ignore the picture, it's just crazy. If this is 120 and I have 30 down here, well, how much is left? 120 minus 30, or sorry, plus 30 is 150. So then I take that away from 180, and I'm left with only 30 degrees available down here. So if that's 30, then indeed this becomes an isosceles triangle, and the answer would be yes, it's isosceles. So that would be assuming that 30 is the smallest angle, which it has to be based upon what we see there. So let's turn the page to the back side. A couple more problems here. All right, says, let's see which corollary theorem works for which things. Our basic theorems were, remember back from your book and lesson today, corollary theorem 20 basically says if the triangles have equal sides, then the angles are going to be equal. And then the corollary to theorem 21 is the opposite. If the angles are all good, then the sides equal. Okay, that's the idea. So when we look over here, let's see, let's look at the first one. Angle B is going to be, let's see, congruent to what? Here's angle B. It's going to be congruent to, well, I have a side, and I have a side, and I have a side. Because all those sides are the same, then angle B is going to be congruent to BAC, it's going to be congruent to ACB. It should be C down here. Sorry about that. It went away. All those things there, and that is because the corollary to theorem 20. This says 4-3. I think it's from an old textbook. We'd actually go with corollary to theorem 20. All right, so next part. If I say the line segment AD is congruent to what? Well, looking at this triangle right here, I have all the insides figured out. And that's going to be the corollary 21. If the insides are all equal, then the outsides are equal. So I could pick any one. I could say AC if I wanted to. I could say DC if I wanted to. And that's going to be the corollary to theorem 21. And again, number 12, back to the angle again. If I'm looking at this angle and I see the sides all work, then that's going to be equal to the measurement of angle either EDC or the measurement of DCE by corollary to theorem 20. Okay. Number 13 and 14. Okay. I'm going to go actually out of order here. You ready? I'm going to start with 14 first, actually. Angle RUV. RUV, right here, this guy right there, is what we're looking at here. RUV is congruent to, well, we look at this and say it's congruent to this guy, which is angle RVU. Now, that is true because of the isosceles triangle theorem. Okay. Isosceles triangle theorem number 20. Okay. And the isosceles triangle theorem says basically that here I have an isosceles triangle, and when the sides are going to be the same, and then the base angles are going to equal one another as well. That's how that works. So now I look back at this number 13, and it says PR. I'm looking at this long line, and what's PR going to be equal to? Well, we probably could tell it's going to be congruent to QR. And the reason that's the case is, well, it's going to be the converse of the Isosceles Triangle Theorem 21. Okay, so that's what our kind of our answers say. So that's what we got. So the converse of theorem 21, converse of theorem 20. So we're looking at the lines with 21, and we're looking at the angles 20. SR, again, back to this one here, same idea. SR is here, so we're going to go with TR, and we're going to go to the converse as well. And that's Isosceles Triangle theorem. All right, number 16. An equilateral triangle is shown. Really small. And it says, and an isosceles triangle. Equilateral here, isosceles here on the bottom. They show a common side. What is the measure of the vertex? Vertex angle. So we have a 60 down here, or sorry, 60 degrees up on this vertex. We already know it's common, 60, 60 here and here, so that's all good. And because we can see this little mark, it tells me this one equals this one. Because this one is equilateral and it's 60, that tells me that inside of this triangle is already a 60-degree angle and a 90, which means that what's missing right there is the 30 degrees. Okay, so I went from a 60, 90 to 30, and I did that just with some quick mental math. If you weren't sure, I could write it out for you. I have a 60 degrees and 90 degrees equals 150 degrees. What's remaining? Well, it's 180 minus 150 to give me 30 degrees I wrote right there. But a 30, 60, 90 triangle is pretty common. So this is a 30-degree angle in that little space right there. What I notice is, with the bottom triangle, I have an isosceles triangle. So if 30 is there, then guess what's right here? Another 30 degrees. And so then I'm back to saying, well, I have a base of 30 and 30. So 30 plus the other side of 30, that's my base. And then I have to figure out, it wants to know what is going to be up here at the vertex. Well, 30 plus 30 is 60 degrees. So what's left in this triangle if that's 60? Well, it's 180 minus the 60 is 120 degrees. So the vertex angle is going to have to be 120 degrees. And that's what we have. Oh my goodness, I was off the page completely. Well, that's a lot of slowness, isn't it? Sorry, there's my work. Oh goodness. So I have a 30 degrees, which I got from coming off of this one, 30 degrees, 30 isosceles, and then I added them together to say that my bases would be 60. So what do I have left for up here? 180 minus 60 is 120. Sorry about that. I hate it when I do that. Okay, looking at number 17. We have angle measurements of 25 up in these little angles, in these corners here, 25 and 25. We have an N down here and an M up here at this point. This line equals this line, which means I have an isosceles triangle. And this line goes to that line, so I have another isosceles triangle. Because, again, they are isosceles, that tells me if that's 25, this little space right here is also 25 degrees. And if that's 25, the other base angle up here is also 25 degrees. Okay? So I can find out M pretty quickly because my base is here. 25, 25 is 50. Well, what's left for that top angle M? It's going to be 130 degrees for M. Alright, no problem there. Now I need to figure out what N is going to be. Well, I have another one of these funny little triangles where I have a 25, 25. That's my 50. That's my base for this triangle. It's 50 here. And I have another 25 already given there. So it's 75, and what's left is n. So I'll do 180 minus 75 to find out what's left for n. 105 will equal n. That's just what happens to be left there. Number 18, another fun little problem for you. We have, again, these lines are equal, congruent. Those are congruent. I have an m down here and an n up here. Because these are isosceles, I have a couple quick little ways of doing this here. This is a 90-degree angle. So what's left with the two 90 degrees in isosceles will be a 45 and a 45. So I know that angle n equals 45 degrees. Now because it's isosceles, and that's 45 and that's 45, and this is congruent to this one, that means that the top of this isosceles triangle, if it's 45 degrees, too big of a degree sign. If that's 45 degrees, then my bases down here are what's left. So I'll do 180 for my whole triangle minus 45, which is 135. Now that's what's available for two angles, angle 1, angle 2. So I have to divide 135 by 2. And when I do that, I end up with 67.5. It's going to be what the value of m will be. Yep, it's a decimal, and yeah, it's okay. So 67.5 degrees. So there's my m and my n. And that's it for lesson, Unit 3, Lesson 5.